7.4 example 4 goes in a bit of a different direction, and it's not a very typical question, but what it does is it gives us the reciprocal, then it wants us to find out the original. Now, the one kind of saving grace to this is they tell us that it was originally a linear function, and that does make the question a little bit easier. Now, you might not remember this, but you really only need two things for a linear function. You need either the slope and a point, or a way to find the slope and a point. Now, what I always recommend to students is that you really need two things: the slope, a point, or a point and a point. If you have either of those situations, you're good to go. So we need some way of coming up with either a point or several points on the original function from the reciprocal. Now, the one thing that I want to do here is I want to do, and we do this in Math 30, but I think it's worth talking about today, that if we talked about any point on f of x, I could label that as x comma y, right? Any point, just an x coordinate and a y coordinate. Where that point goes to on the reciprocal is x comma 1 over y. And we've seen that throughout the examples. Hopefully you understand that's happening. It's really important that that's just as true in the other direction. So if I took any point on the reciprocal of the function, if I take the reciprocal, I get the point on the original curve. Now, that seems like we're just going in a big circle, and if you do both, you are. If you take the reciprocal twice of any number, you get the number that you started with. So it's really important that what we're going to do in this example is we are going to grab or try to grab 2 points. And the point that I'm going to grab first is 3 comma 1/3. That was a given point to us on the reciprocal, so we can identify that originally on the original function, this was 3 comma, the reciprocal of 1/3 is 3. Now, we're kind of halfway there. We know that 3 comma 3 is on my original function. What I need to do next is try to find out another point, or several other points if it's possible. And the best way of doing this is the part that I kind of skipped, which is to draw the original function. And the way that we do that, the way I like to do that, is I like to find my invariant points, which is when y is equal to 1 or -1, and then really just connect those dots. I didn't connect them very well. It should actually go through that point right there, because on f of x, we would have an x-intercept of 2 comma 0. Now, there's another way of telling that. On 1 over f of x, we have a vertical asymptote at x equals 2. These two concepts lead to each other. Now, the reason why that's so powerful is now we have all the information that we need. I know on f of x, we have the points, or I put has points, you can put goes through points, whatever it is, but it's going through the point 3 comma 3, and it's going through the point 2 comma 0. That's all we need. Because in order to get the equation of f of x, I am going to put it into y equals mx plus b, keeping in mind that b is the y-intercept, and m is the slope. The way that we find our slope, m is equal to, and I'll put that general form, y2 minus y1 over x2 minus x1. The slope for this linear equation, and it doesn't matter what order you put these in as long as you're consistent. So because I read left to right, this is going to be 0.2, this is going to be 0.1. So it's y2, which is 0, minus y1, which is 3, divided by x2, which is 2, minus x1, which is 3. And what I get is -3 over -1, or 3. Now, before we keep going, it's really important that when we do work like this, we should see that on the original function. And if I look on the original function, I think it's pretty reasonable to say that it looks like that graph has a slope of 3. If nothing else, we could take a couple different points along the way and talk about exactly where they go to. And if 3 comma 3 is on that graph and 2 comma 0 is on that graph, well, I go 1, 2, 3 units up, that's my rise, and 1 unit to the right, that's my run. So pretty clearly that black line does have a slope of 3, or 3 over 1. That's all we needed. Because now if I look at my y equals mx plus b, I know that it's y equals 3x plus b. Now you have a choice. You can use either of these points. It does not make a difference. I always recommend to students use a point that has 0 if you can. What's really important is that that b value has to be such that 2 comma 0 is on that line. So if I put 0 in for y and 2 in for x, I get that 0 is equal to 6 plus b. When I subtract 6, I get -6 is equal to b. I want to show you it works with both points. If I put 3 in for y and 3 in for x, what I get is that 3 is equal to 9 plus b. I subtract that 9, I get that -6 is equal to b. And it's really important that using either of those points should give me the same result. because both of those points are on the same line. So they have to have the same equation. Now, the last part of this, just to summarize what we've done, we've identified that that black line is y equals 3x minus 6, but it wants the original function. So use that function notation when you're asked for it, and f of x would be 3x minus 6. Now, they don't ask for it, but just one last time, if f of x is 3x minus 6, 1 over f of x is 1 over 3x minus 6. And this is a great way to confirm that it is the graph that we were given, or the graph that we were looking at. Okay, I'm going to put up the assignment here. Keep in mind that if we are using Google Classroom, which we are, you check for that modified assignment because we are taking, okay, I'm just having a bit of struggle here getting to the actual assignment page. Sorry about that. That is the assignment with the review, but we will be putting that modified assignment in Google Classroom. All right, good luck. Chip away at it. If you have questions, don't forget to email.